Hello and welcome to my new video. This video is on cylinder and flat zone. In my previous video, I talked about Likkerin. So before going to engineering part, I am talking some general description of cylinder and flat zone. So the distance between Likkerin and cylinder is 0.127 millimeter to 0.178 millimeter, and the draft between these two zones, that means draft between Likkerin and cylinder, is 1.5 to 2.5 is the draft is 1.5 to 2.5. And now look into this two zone. This is cylinder and this is flat. Actually the flat is consist of 100 to 120 flat bar. Each flat bar width is 32 to 35 millimeter width, and the length of flat bar is same as cylinder length. So this all 100 or 120 whatever the flat bar number, this all flat bar makes the flat endless path, and slightly less than 50% flat bar are active. That means around 40 to 46 flat bar are active at a certain time. So now look carefully. The wear direction of cylinder is in this following direction, and the y direction of flat is in that following direction. The red color is y direction of flat, and the black color is y direction of cylinder. Okay, and the rotational direction of cylinder is in this way, and the flat is in that way, that means in opposite direction. So this is very important because the main carding action is occur in this zone. Okay, the point density of wear is around 250 to 550 point per square inch, and the wear angle of cylinder is 12 degree to plus 12 degree. Actually in terms of wear it can be plus and minus. Only minus is in Likkerin. The wear angle of Likkerin is plus 5 degree to minus 10 degree. Okay, and the wear angle of cylinder is plus 12 degree to plus 27 degree, and wear angle of Doppler is plus 20 to plus 40 degree. Actually this wear density and wear angle is very important because the cleaning efficiency, opening efficiency, and fiber individualization, naps opening, all these things are depending on wear angle and wear density. As we already have said that the wear density is 250 to 550 point per square inch. In terms of coarser fiber, we use the lower point density, and in terms of finer fiber, we use the more higher point density. Now, the main task of this carding action in this zone: fiber individualization, short fiber removal, naps opening, and dust removal. These four main tasks are operated in this zone. So now look into how they individualize fiber. So before going to this, we should look into this picture. Suppose that this is the front view of cylinder and this is the front view of flat. So the wear of cylinder is, and the wear of flat is. That means each and every wear of flat is between two wear of cylinder, or each and every wear of cylinder is between two wear of flat. So whenever a fiber goes through this line, then it straight the fiber in that way. That means it is flat wire and it is cylinder wire, and they are going through this direction, those direction, and there, and this is a fiber. It ultimately parallelizing the fiber in this way. Okay, and the point per fiber is 10 to 15 wear point per fiber. That means per fiber is beaten by 10 to 15 points of cylinder. So this is how actually fiber are become individualized and fiber are become parallelized. And now the second one, the naps opening. Actually naps opening is also done by the same way, the action between flat and cylinder. Now in terms of short fiber removal, a short fiber has less contact with cylinder wear and a long fiber has more contact with cylinder, and that's why a long fiber will retain with cylinder and a short fiber will retain with flat bar or flat, and this is how the short fiber will be eliminated, will be removed from this